Hi everyone. Uh, this is Michael from Celer, and I'm a core developer at the Celer Network project. And uh, today I'm going to talk about how to build a one-click UX multi-chain dApp with the cBridge and Celer Interchange Messaging SDK. So first off, I guess I should do a little bit of introduction of what the Celer cBridge is. So basically, cBridge is this blockchain interoperability protocol that we at Celer built. Um, so basically, um, it supports both asset transfers across the blockchains and also like general messaging across different blockchains. So architecturally, it's actually a pretty decentralized way of sending information across. So we built this a relay chain called State Guardian Network, SGN. It's a relay chain based on the Cosmos SDK and Tendermint proof of stake system. So basically, you can stake Celer tokens on Ethereum, and your stakes are then synced to the SGN. And so basically, like with this like proof of stake system, it becomes this like decentralized way of securing asset transfers and information across the different blockchains. And we actually have two modes of operations for the cross-chain bridge. So we have this liquidity pool-based bridge where we have internal like AMM. It's like curve. It's the same like it's a similar curve like the curve finance like stablecoin swaps. So basically, you can swap assets from one chain to the same asset on the other chain, and there's like a little bit of fee charged in that. And also we have this like peg bridge, which basically you can do like one-on-one mapping between the original token and the peg token on another chain. And finally, you have this thing we call Celer IM, which is this interchain messaging framework to support generalized smart contract calls across different blockchains. So currently, we're already connected to, I think, around like 20 EVM chains, and we're also expanding to non-EVM chains in the very recent future. So let's do an architecture overview of what the. So I guess first of all, I should like show you a little bit of like how the UI looks like. Let's see. Yeah. Yeah. Here is the cBridge UI. So here on the liquidity tab, you can see a bunch of tokens, and those are from the first type of bridge I talked about, the liquidity pool-based bridge. So for example, we have say USDC, and we have like liquidity pools for USDC on multiple EVM compatible chains, including the BNB chain. And we have about like $7 million of liquidity there, and we actually support farming. So like if you provide liquidity on one of those pools, you actually earn Celer tokens on top of your bridge. Like on top of your bridge fees, you actually earn like Celer tokens as extra reward. And the transfer tab lets you like actually do the transfer across different blockchains. So that's the general overview of the cBridge UI. And there's this like SGN staking where if you click on that, you can actually like stake your Celer tokens and to provide security for the network for the relay chain. And there's like extra reward earned. So basically, you get like half of the all the bridge fees if you stake Celer tokens. Right. So I'm not going to go into like too much details of the staking part, and it's just like diving to the building. Okay, so let's do like a little bit of architectural overview of how the system works. So as a user, you first go to visit, say, the application, and the cBridge.Celer.network is one of the applications, the cross-chain bridge, asset bridge application we built on top of this system. And So via a set of SDKs and kind libraries we provide, you can talk to the cBridge gateway over here in this yellow box, which is it's kind of like a proxy to the SGN, which is the relay chain we provide. And basically, the user sends a so the user first sends a transaction to the cBridge contract over here in this sort of like blue box over here. It basically says like I'm going to transfer say 100 USDC from say Ethereum to BNB chain, and then the SGN is going to listen to that transfer event and basically they do like a round of like validation on top of that. It's basically like all the SGN validators are going to verify that the event did happen on Ethereum, and they're going to relay that onto the BNB chain. So and the gateway is here to provide like a supplementary like network request. Basically, the user is going to know like how much they're going to receive on the BNB chain minus the fees, because the SGN like the validators gets to decide like how much fees they're going to charge for the relay. It's going to cover the little bit of gas cost on BNB chain plus the liquidity fee for like basically like you kind of want to like make the liquidity balanced on the two chains, right? So like you have to charge a little bit of like a liquidity rebalancing fee from the user. And so once the request gets relayed to the BNB chain, the relayer is going to call like one of the SGN validators is going to call the cBridge contract on the BNB chain, which is the destination chain, and the user is going to receive their USDC, like 100 minus a bit of fee on the BNB chain. So that's like a pretty straightforward architecture. It's basically the relay chain that just monitors on-chain events, and they do a round of like multi-sig on top of that. Yeah. So here we talked about just a little bit. We have like two bridge modes: the liquidity pool and the mint and burn bridges. It's more like a one-on-one mapping. So basically, instead of doing like liquidity pools on both chains, you can lock original tokens on one chain, and then the SGN is going to mint the pack versions on the other chain. And if you want to go back, you can just like burn the pack of tokens, and they're going to release the original tokens on the original chain. So I guess like now we can have an overview of the like how you're going to build stuff on top of this. So we have this pretty good doc site, cBridge docs.celer network. So we can click on that and see what we have. So we have this like picture here that shows the same like workflow, and we describe how you like install the you can like install the SDK, which is essentially just like a set of libraries that you can use and to talk to the gateway. And there's like also the API reference for so how you do say like pool-based transfer, and talks about like how you can talk to the gateway and the contract for to complete a pool-based transfer. And then there's the mint and burn like pack bridge. Yeah, and so there's like there's just like an overview section, and there's like a more detailed API reference for different types of operations. So basically, so for example, to send a token from one chain to another, you can just like call the contract first. So just if you just want to like send tokens, that's pretty simple. You just like call the contract and specify the destination chain and the amount and all that, and the SGN is gonna the state guardian network is just gonna relay that. And it gets into like more complicated stuff. If you want to talk to the gateway and say like get the status of the transfer, there's an API for that. And sometimes like the transfer can fail because like as I said, there's like in the liquidity pool-based bridge, we have the liquidity pools, and sometimes like they become imbalanced, and then if you're gonna receive less than what the user specified, then there's situations where refunds can happen, and those can get more complicated. But we kind of ignore that for now. And there's also like an API to get transfer history. You want to like display a nice little like history for the users. And so I think the docs are pretty complete, although it's not like the most organized at this point. But we have like if you want to build on top of this, we're like all here to support in terms of like how, and we have like examples and the support team ready for that. Yes. So take a look, take a read at all these links, and that's for the cBridge. And now I'm going to talk a little bit about the Interchain message framework that's built as a separate module on top of cBridge. So basically, you have like you know how to complete fund transfer across different blockchains, but you don't want to like stop at that, right? You want to do more generalized messaging across the different blockchains. So for example, you want to do, if you're building a DeFi, like multi-chain DeFi application, like there's one use case which we think is pretty useful. So for example, the user has some token on one chain, and then they want to buy another token on another chain because there's no liquidity for this particular token on the home chain, say for example, on the source chain the user is using. Right? So the user might want to just like send the tokens across to another chain and purchase the token on the DEX over there and send it back to the source chain. So this is like a scenario that could be useful for some users because they don't want to go like manually go through the bridging and swapping, and they can just like go to this like unified cross-chain DEX, and then they can just like in one click complete the action and wait for a little while, and then the token is going to end up back in their wallet. The token that they're going to want to purchase is like back in their wallet. So that's like pretty nice user experience. We imagine you can like achieve with the interchain messaging framework. And there's also like a cross-chain governance where you have like this the different versions of the governance token on different chains, and you want to be able to participate in governance from any of them, and that's also possible with this interchain messaging framework. Yeah, so this is a pretty it seems like a complicated picture, but it's really like pretty simple. So this is the workflow for a message with fund transfer. So basically, I mean, before like diving into picture, there's like this high-level idea of when we build the system. So basically, we build the system as something that's built on top of the fund transfer. So basically, the idea is that you can send a generalized message across with your fund transfer. So this is like something you actually cannot do with the regular ERC20 because when you do regular ERC20, there's like no extra message you can put in. Like it's just a simple fund transfer, and you actually have to implement your custom logic if you want to do basically when you if you want the contract to like do something when it receives a particular token, you have to actually build a whole host of like customized logic on top of regular ERC20 transfer. So with the cBridge messaging, like interchain messaging, it actually make it pretty simple to send a message across chain along with the fund transfer. So basically, these blue lines are the regular fund transfer workflow we just talked about in the previous slides, and now we added these green arrows over here, which represent the messaging flow. So you see like the two lines are actually happening in parallel. So basically, I mean the picture doesn't say it very clearly, but like basically the two are happening at the same time. So first you have the TX by the user, like dotted box down here. So along with the token transfer in the blue arrow, they actually send some message along with the token transfer. So we have this like a message bus contract on the source chain, which is composed of two components, right? The message sender and the message receiver on both chains. So to the message sender, the user is going to send this token transfer, and along with the little like message that says, well, for these like for this particular transfer, I'm also going to call this like other contract on the destination chain with the tokens I'm going to send over. So via either the liquidity bridge or the peg bridge, they both support this like extra messaging property. And once the XGN sees that event and it picks it up, and the validator is going to verify that the event actually happened on the source chain, they're going to relay that both the fund transfer and the message over to the destination chain, to the destination cBridge chain. And the message is going to so the message bus contract on the destination is also going to see that, okay, a fund transfer along with the message has arrived. So so now we have this like another component that's like to the right hand side of the SGN here, the executor. Basically, it's a separate binary that can be run by anyone. So preferably just by like the app itself that builds the app, basically the builder, developer of the cross-chain app is going to run this executor binary that watches all the event that arrive on destination chain. So once like the event is verified and relayed by the SGN, the executor can execute the message that has arrived at the message bus on the destination chain. And then this message is going to call the destination app on the destination chain and trigger like whatever actions the user specified. So it could be like a swap on the DEX, or like a vote in or a stake in a staking contract, or like a vote in a governance contract and that. So yeah, that's pretty much the overall workflow of message with fund transfer. I mean, of course, like you can build the app that just does like message a cross-chain smart contract call with no fund transfer. That's obviously is supported. So this is like a simpler. So without the blue arrows, you just have the green arrows where the user sends a message from the sending app to the message bus on the source chain, and the SGN watches the source chain and relays that information over to destination chain. And once the executor, the same deal, the executor sees there's a message arriving on the destination chain, they're going to execute that and call the destination app on the destination chain. So it's pretty straightforward. And the and the user just like sends a TX from the source chain, and it automatically gets relayed on the destination chain and gets executed by the executor binary. So yeah, same way we actually have like a separate doc site for the Celer Interchange messaging, and so this like im-docs.celer.network is where we have this Celer IM. Yeah, so it provides a pretty nice overview of what the IM framework does, and there are like examples we have. I mean, it's not like basically for this like hackathon, we actually welcome anyone to build apps on top of the either the cBridge framework or like the IM, preferably the IM, because I think we think like the interchain messaging is going to be like the more useful than just like fund transfers. Yeah, you see like we describe like some examples you can do with this like messaging framework. And well, there's like a little bit of simplified, I guess, different illustration of what the workflow I described, but it came with like nice description of what each step does. Yeah. And we actually have, let's see, yeah. We actually have a set of contracts. So by the way, like all our contracts are already open source and they're visible on our GitHub, and it's under Celer Network sgn-v2-contracts, and everything under this message folder is what the Celer IAM contracts are. And so under this like framework folder here, we actually provide the set of contracts you're going to import, or you can just copy your IAM apps implementations. So we have this like abstract contract message sender app, which like has the handy functions you're going to use when you want to say like send message with transfer. And we actually it calls into a library we provide. And if you don't want to inherit from this message sender app, you can just like separately use the message sender lib here, which actually does the bulk of the work that calls into the two types of bridges with like the extra like computation of say the transfer IDs and all that. So we have like pretty good documentation on the contracts themselves. So if there's anything, you can just like read the docs here, and if there's anything you still don't understand, you can just like pin us in our Discord channels, and we'll be going to be able to answer all that. Yeah. So basically, we also provide a couple of examples. So for example, this thing called batch transfer is actually pretty. Personally, I think it's a pretty useful contract, or it's a pretty useful app to have. So instead of just like sending a single type of asset, right, you now have a way of sending a batch of transfers from the source chain to destination chain, and this is done by the messaging framework. So sorry, it's not like it's still a simple type. It's still a single type of token, but instead of like sending it to one receiver on destination chain, you can send it to a batch of recipients on the destination chain. So it actually does the splitting and the sending on destination chain. So instead of like a single receiver, you can have like multiple of them. So which I think is pretty useful if you want to do like a cross-chain airdrop, if you think about it. And so yeah. And we have like a nice description of what each components do. And yeah, and then there's the executor binary I was talking about. So so unfortunately, right now it's like the binary isn't open source. We're in the process of cleaning things up internally, but it will be like open source pretty soon. But probably not in time for this particular hackathon, but we will like in the future. But we do provide like a pretty good documentation of how you can configure the executor and run it for your particular app. So the idea is that you provide start this like executor, and you give it a config that watches this particular contract that you're interested in on the destination chain, and it's going to query the SGN. It's going to query the relay chain for all the messages pertaining to a particular contract you specified, and then execute them once it sees that one message comes in. It just like executes that. So that's like basically a binary you can use. Yeah, and it's under the binary folder here, and you can like download the executor. We're going to do like a little bit of cleanup here, but you just like find the highest version and just like download that, and it should be able to get it up and running. Yeah, and we're going to talk about like the fee mechanism just a little bit. So to prevent spamming the SGN, we actually charge a very like a little bit of fee when you actually send a message. So the send message with transfer is actually a payable function on the source chain, and you're required to put in a little bit of a like a native token in message value to just to like compensate the SGN for the message storage. But it's not like a very high. It's in terms of like a low ways. So like you actually pay just a little bit, and we have like a base fee plus the a fee per byte. That's basically like if you have a larger message, you're gonna pay a little bit more fees. So, but overall, it's a pretty minor fee compared to say like the bridge fee. It's pretty minor. And also, like as an app builder, you might want to charge the users in terms of gas fees on the for the executor, right? Because the executor has to pay for gas fee on the destination chain. You might want to have a way to like charge the users for the cross chain, or you just might want to provide it for free. So it's entirely like your decision to charge an executor fee. And we don't like enforce any kind of a fee for the executor fee here. Yeah. And here we have we actually provide an integration guide, which is more of like a walkthrough of a demo. So it's pretty complete, and yeah, basically, so I was talking about this like batch transfer contract here, and this particular integration guide actually walks you through how you actually built this like batch transfer app. Yeah, and yeah, just like follow it if you have any questions, just like payments, and we'll be able to. I mean, some parts like might be the docs are like pretty new, and there's like could be errors here and there. Could be like steps you cannot follow, and just like payments, and we're gonna fix those and tell you like what to change. And there's like an advanced guide which talks about like more advanced topics. Like first of all is like chaining of the messages. So the idea is that like instead of a simple message, instead of a single message you send from source to destination, you actually can do like message chaining where you send a message from the destination chain back to the source chain as a receipt. So that's like some one use case we think that the chaining could be the most useful. So if you want like there's a message that acts as a receipt sent back to the source chain, you actually can trigger that when you execute the message on destination chain. You can just like trigger another message that gets sent across. And there's also like dealing with bridge failures. So I talked about that a little bit before. So basically for the liquidity pool based transfers, there are cases where the bridge can fail to relay your funds depending on your settings. And because, so for example, like if you send an amount that's too small to cover the gas costs on destination chain, the bridge is going to say like, I'm not going to relay that. The SGN vendors will refuse to relay that, but they will sign a signature that you can use to get your funds back from on the source chain. And also, like of course, the message executions themselves can fail because I mean, it's smart contracts, and so for example, like the DEX, if say like a price of a particular token change drastically on destination chain, and the swap can fail to execute, right? And you're gonna have to like actually handle that on the destination chain. So we actually have all the mechanisms built in, and describe like some of them here. But of course, like because it's more of a these are like more advanced topics, and kind of have to like deal with them on a case by case basis. Yeah. So